Hey guys, this is Ed from Mission Impossible. Welcome back to my Atari 8-bit assembly language programming tutorial. Today is episode 20, and we're continuing with our efforts to do the map generation. This time we're going to be adding the ability for the map generator to walk between rooms. So we're going to have multiple rooms connected by doors. We're going to have our down tile placed, and it's actually going to be starting to look like a real map. So let's get into it. So the first thing we want to do here is we want to create some macros for these getting the room number and getting room position, because we're going to be doing this a few different places. So let's go ahead and do that. So we're going to say macro, let's say get room num. Just going to put this right here. And we're also going to do one for the room position. Okay, so they're going to be ran, and then they'll just store the information in the variable here, room type or room position. So we actually probably want type instead of room now. Okay, and we'll just call these right here. We're going to be updating this function here soon here, but let's just go ahead and put these in. Get room pause. So now we have it so that it'll get the room type and the room position for the first room. The next thing we need to do is set up the number of rooms and the max number of rooms. Num rooms, and we'll put that in B0, and max rooms, we'll put that at B1. So we're going to keep track of how many rooms that we've created, and we're going to then compare that with the number of rooms that we want. On the first level of the dungeons, we don't want to have it be fully populated. We want it to be smaller. We can do that easily by limiting the number of rooms. So we now have num rooms and max rooms. So in here, we're going to go ahead and set those 0 to the num rooms. And we're going to say, to start, let's do like 4 rooms for the max rooms. Kind of want to clean up a few things here that we were going to need to do. So place up tile. One of the things that we're going to want to do here is also be able to place the down tile. So I'm actually going to change this to place special tile. And we're just going to use map up. Let's see. So we used in our, if we remember, we used in here, we have map up and map down. So we're going to be using that here. So we're just going to say map up. And then in place up tile here, we're just going to say place special tile. And then we can load that in the Y register. And then we can just say, actually, let's load that in the X register. And then what we can do is when we're ready for it, right here where it says load map up, we can say, instead of doing that, we can say TXA, and that's going to load in to the accumulator whichever tile we want to use. Okay. So let's make sure that that still works. Okay, yep, still works. Good to go. No problems so far. Okay, so now I want to fill in the new map procedure with all the code that we're going to need for today. One of the things that you'll notice is that I've been going around and removing the parentheses here, and that's because when you start using the procedures, it really doesn't want you to have parentheses there. So it's a little odd having them in some places and not in others. So I've been removing them there. So let's go through here. I'm going to say we get the room position and the room type. And we're going to do a copy room just like we have. Now this is going to be for the very first room, okay? We're going to be doing something different for each additional room that we're going to be adding. But we're going to go ahead and increment the number of rooms here because we've added the first one. And we're going to jump down. I'm going to go ahead and create a label here called place. Okay. And I'm going to say jump to place. So it's going to jump down to place that room. I'm also going to add here a label for that. I'm going to actually just do this. I'm going to say first room. This is not needed at all, but it makes it a little bit clearer when looking at the code. This is what we're going to be doing for the first room. This is what we're going to be doing for the last room. So we're going to say place special tile map down. And then we're going to go ahead and place the room, which we haven't. Actually, yeah, we have that function already. And then we're going to jump down to done. Okay. Go ahead and remove that for now. So we have done down here. Next thing we're going to do is we're going to do next room, which is this just going to be all the rooms in the middle. It's not the first one, it's not the last one. What we're going to do is get room type and copy room. Okay. Now, one of the things we're going to want to do here is we're going to want to check to see if it's the last room. So we're going to just put that in here, check last, and we're going to do increment. Actually, I want to put in here, I want to put increment number of rooms, and we want to compare. So we're going to do load number of rooms, compare to max rooms, and then if branch if equal, we're going to go to the last room. So it's going to jump up here if it's the last room. Okay. And now in our place label here, we're going to say place room. And we're going to say get doors. Now we're going to use a procedure here we have not created here. It's called walk room. So the idea here is that we're going to place all the stuff in for the one room, and then we're going to keep moving between the rooms. So I'm going to go ahead and put it there, but I'm going to comment it out right now so we don't have assembly errors. And then we're going to say next, or rather jump to next room. And then when we're done, we're going to place the doors. The very end, we're going to place the doors, not rooms. Okay, so this is the new skeleton of our new map here. So it's going to go through, it's going to create the, it's going to fill the map with walls. And it's going to do the first room. Then it's going to skip down here to place at this point here. And it's, it's going to place the room. And then get the doors and then walk to the next room. And it's going to keep doing that. And so we're going to say jump to the next room right here, gets the room type, copies the room, increment the number of rooms, make sure it's not the last one through here. And then if it is the last one, it'll jump up to this last room and then jump to done. So it's a bit of jumping around. And there probably is a better way to do this, but this seemed to be the most logical to me at the time. Okay, next we're going to have to change the way we're dealing with the doors. So right now we are using, let's see, we're using room doors, which is not a very good label. We're actually going to need to keep track of the doors that we've placed as well as the doors that are available. So I'm actually going to rename this to doors avail. Actually, room available? No. Doors placed. Placed doors, actually. Placed doors. Okay. Doors that have been placed. Now, place is a little bit of a misnomer here. We haven't added them to the map yet, but these are actual doors that we're going to be adding to the map. So we have also avail doors. So these are the doors that are going to be available. So we're going to say that's going to be in 7329 doors that are available 64 bytes. Okay, so with that, we're going to need to set up pointers for those as well. So I'm going to go ahead and put these down here. Well, at some point I'm going to need to organize my 0-page addresses here, but that's okay. So we have a placed doors pointer. Let's go ahead and put that at B2. Avail doors pointer, and put that at B4. Remembering to skip a byte there, so we are good to go there. Okay. So any place that we were using room doors, we want to change that to Avail doors. So let's go ahead and find everywhere we're using that. Room doors. So let's just go ahead and I'm just going to change them manually just to, while I'm looking at it instead of doing a global search and replace since there's only a couple of them. So sort back into available doors. Same with this one. Okay, that's all there is. Okay, so we've now renamed the doors or room doors to available doors. That's going to make a lot more sense as we're doing this. Okay, so the next thing we're going to need to do is we're going to need to set up an array for the occupied rooms. We need to know as we walk through them which rooms have been occupied already. So we're going to go ahead and add that right here. Okay, rooms that are occupied. Now this will only take up 8 bytes. And the reason why is because we only really need to use 1 bit for each of the rooms to be able to show if they're occupied or not. Now, in order to do that, we're going to have to do some bit shifting, but it's worth it to be able to save the space. So we're also going to need room column and room row. So let's go ahead and put that down here. Room call B6 room row. This is going to make things a lot easier trying to calculate the position. So we're going to put that in B6 and B7. The way to look at doing bit shifting here is by looking at it as being each position as being a new power of 2. Starts off with 2 to the 0th power, which is 1, 2 to the 1st power, which is 2, 2 to the 2nd power, which is 4, and so on and so on. So we're going to need to be doing a lot of shifting, and the easiest way to do that is by using powers of 2. Since there is no way to do power function in 6502, what I want to do here is create a lookup table of the powers of 2. We don't need all of them, we just need a few of them. So I'm just going to go ahead and put this at the bottom here. And just going to call it powers of 2. So 1, 2, 4, 8, and goes all the way up there. It only takes up 8 bytes, not much. And we need to set up a pointer for that. So let's go ahead and put it right here. Power 2 pointer and B8. Okay. And that's going to be a 16-bit as well. Okay, we're also going to need to set up a pointer for the occupied rooms. So let's go ahead and do that here. And then at the beginning, we need to set up a pointer to it. So let's do it. MWA powers of 2 to POW2 pointer. Okay. I'm actually also going to set up MWA occupied rooms and occupied rooms pointer. This might be something we want to do somewhere else, but for now this is fine. So now we're able to finally set up our occupied room procedures. Okay, so first up, we're gonna do get room occupied. It's going to be loaded in the room number. It's going to be loaded into the accumulator. We're setting up bitmap as our temp variable here. We're going to mask the last 3 bits and save them as the column. And then we're going to divide by 8 to get the row. So, let's see. We go down here, store the room row. And now we have, at this point, the column and the row set up by basically doing a combination of mod and division. And so we have now, we're going to copy the accumulator, the room row, into Y. And then we're going to go through and look at the occupied rooms pointer. Now we're going to store it, store the bitmap. Let's just do that. Store bitmap. So first we're going to load in the bitmap from this occupied rooms pointer. So basically what we're doing here is we have 64 bits. So that's going to be 8 bytes that are full of this huge bitmap. Okay. And so since we can only really deal with 1 byte at a time, we need to shift over as needed. So that's what we're doing here. So we're saying we load in the occupied rooms pointer, comma Y, which is going to say where it is in the row, okay, or where we are in the bitmap. Think of it like this: the 64 bits are set up in 8-byte chunks, and so each of those 8 bytes is going to be the row, and then within each of those 8-byte chunks is going to be the column. So first we're going to shift over to the correct row, and then we're going to shift over by the column. And the way we do that is we're going to load in the column, copy at the Y register, and now we're going to use the power of 2 pointer that we set up to be able to shift over that many to be able to AND it with that value. So that's going to get the value of that particular bit position, okay? And it's going to be storing it in A. So it's, a bit of a tricky thing to save that, much space, but it's much better than using 64 bytes of RAM to be able to do this when we can get by with only 8. It's a little bit more code, but it makes a lot more sense to do it this way. So I'm going to go ahead and copy in the procedure for setting the room occupied. It's a very similar thing. The only difference is that we're going to be setting the bit versus getting the bit. So we do that with an Aura to OR them together. And then we save it back to the bitmap. Hopefully this makes sense. It took me a while to get here, but basically having to do the divs and mods to be able to make it work. So we now have set and get room occupied going. Now we can actually do the walk. So we're gonna do that next. Future Ed here. After doing some editing on this, I just realized that all the space that I was saving by using this bitmap was negated by the fact that I had to use a whole bunch of code to get there. In fact, the amount of space that I used for the code was actually more than the space that I was saving. So in a future episode, I'll remove all that. It just goes to show you, premature optimization is the root of all evil. Back to me. Okay, now we're going to be able to create our walk procedure. Okay, so let's go ahead and do this. So walk room, and we're going to create a label here called pick, because we're going to be going through and picking a direction. But first thing we're going to need to do is we're going to say WA place rooms to place, not rooms, I keep doing that, place doors. Place doors pointer, Avail doors, Okay, so we're going to load in the room position. And then we're going to load in the Avail doors pointer, Y. So the room position is our offset here for the available doors. And then we're going to store that into a variable called doors, which I'm not sure if we have set up. Let's create it. Doors. We're just going to put it in BC. Okay. And so we're going to load it in the available doors, and we're going to store that into doors, so we don't have to reference it all the time. We're going to do a random 8. Pick a direction. We're going to use that, and then we're going to say and it with 15, and then we're going to say and it with doors, and store it into doors. So what this is doing, it's grabbing a random number. This is going to be grabbing the last 4 digits of it, and it's going to be ANDing with the available doors that we have. Now, if you remember, we set up the room doors variable to say what are the available doors that for this room based on the position in the map, as well as the doors that are available for that room type. So that's already set up. We're just loading those in. And what we're doing here is we're going to be ANDing them with this random number that we get. And then we're going to check it to see if it's one of the 4 cardinal directions: north, south, east, west. Now we're going to check it to make sure it equals one of those, because we don't want it to be like picking left or east and north. It's like we want it to be only doing it if it's only north, if it's only east, if it's only west, stuff like that. So we don't want to make things confusing here. So we've picked the number. Now what we're going to do is we're going to check if the north door is, if it's the north door. So I'm actually going to create new labels in here. Actually, there's going to be new procedures for each one of these. So we're going to check the north door, and then we're going to say, basically, if it's not there, then we're going to check south, and we're going to go through it. And if it is there, so we're going to say walk north, and then we're going to say our room position. Jump, done. So we have 2 new procedures we have to create here. One for check north door and one for walk north. Now we're going to need one of these for every single one of these. So check north, check south, etc. So I'm going to go ahead and copy and paste those in. Okay. So we have check north, check south, check west, and check east, and then we're done. So now we'll go ahead and go into the checking of the individual doors here. So we do proc check north door, and then we're going to load in doors, compare it with door north. We're going to say because if you remember, we have our label set up. Door north is, the 8, 4, 2, 1 in these bit positions. So we're going to say we load in the doors here, and then we're going to verify that it is only north. Okay. If not, we're going to go to a label down below. We're going to call it false. Okay. And we're going to say LDA 0. We're going to basically say the A is going to be set to 0, and then RTS and P. And if you look right up here, when we do that, then that's when this is going to trigger. So it's going to be set to 0, and then it'll work right here to be able to check the next place, next, etc. So we're going to say LDA room pause sub 8. Store into temp, get room occupied, temp, BQ true. So at this point, we're saying, make sure that the room's not occupied. Okay, let's go ahead and put that. And what we're doing here is we're saying 8 as in the room directly north of us. And we're just verifying that the room is not occupied. If it is north, if it's exactly north and the room to the north is not occupied, then we go ahead and we're going to skip down to true. Okay, then we're going to LDA1 RTS. So at that point, A will be equal to 1. That means it's a true value. 0 if it's false, etc. So in this case, we're going to say LDY room pause, and then we're going to say LDA avail doors pointer Y sub door north and store avail doors pointer Y be any false. So this is the case where the room is occupied. Room is occupied. So at that point, what we want to do is we want to say we don't want to be able to go that direction. Eventually, we may want to change this code to be able to allow us to go there. But for now, we're going to say if the room is occupied, go ahead and remove the door from the available doors. Okay, so it subtracts door north from there, and then so it removes it. Okay, so we've done the check door north door. Now we have to do a check south, check west, check east. So I actually have these already written, so I'm going to go ahead and copy and paste them. Sorry for a lot of copy and pasting this time. It's just there's a lot of code. So I'm going to go ahead and put those in there. So we have check north, check south, check west, and check east. The code is very, very similar. The only thing that's different really is that for west, it's sub 1. So that's, going to the left. East is add 1, and then south is going to be add 8. So it's all pretty much the same stuff. And so that's 4 of the functions that we needed to write for these check functions, these check procedures. They're done. Now we need to actually do the walk. So we have a walk north, walk south, walk west, walk east. So let's go ahead and do that. So I actually have some decent comments for this one, so I'll go ahead and copy and paste that. Try to go slower, I guess. So we have walk north. Y is going to be the room position, updates the current and available place doors. Current available and place door, yeah. Moves position to the new room, updates the new available doors to prevent backtracking. Okay, so we're going to say we're going to add the door to the place rooms in the current room. So we load in place doors for whatever the room position is. Then we add door north and then store it back in. So we're going to say, okay, the place doors means that we are walking north. Okay, that it's going to be a door that's going to be placed in the world eventually when we get to the place doors procedure. We're going to remove the door from the available doors in the current room, basically to make it so that we can't go back. At the end, one of the things we're going to check is to see if there are any available doors. When we want to be able to, when we hit a dead end, we're going to want to go through the available doors and see if there's a door that we can go through. So we want to remove that from the available doors. Then we're going to move the room position. So it's going to go north. So the map room columns, this is probably better to say, instead of saying 8 and, stuff like that, it's, I should go up and change it, but map room columns, this is 8. We're going to get the doors, remove the available doors in the new room. So basically what we're saying is if you walk north, we need to remove the north door in the bottom room and then remove the south door from the top room. So that way we don't have any available doors either direction. So that's it for walking north. And I'm going to go ahead and copy in the other ones. Exact same procedure. So we can do that. So now we have walk south. It's adding door south to the place doors and removing door south from the available doors in the current room, and then removing door north from the new room. So exactly the same thing as walk north, is just reversed. And the same thing goes for the west and east. Okay. So now that we have that, we should be able to uncomment our walk room procedure. Let's see what breaks. Okay, undeclared map room columns. Okay, so that was the new thing that we used. Let's see what that is. Map room columns. Yes. So, in an effort to try to remove magic variables or magic numbers, we now have map room columns and map room rows. Let's see if that gets better. Okay. Well, it didn't blow up, so that's a good sign. Let's see if my joystick's working. Okay, cool. Let's see. Do we have a room? Looks like we have an issue here because we started in a room that doesn't have a down a down tile, or up tile, I should say. There's our down tile down there, and we don't have any doors. So let's see what's going on here. Oh, I know what the problem is. So there was some function. There was a procedure we needed to change, and let's look at it here. Place room, I believe, was one of the ones that needed to be changed. Okay, so in place room, we're loading in the room position. We need to set the room occupied anytime you are in here. So we didn't call set room occupied for room position. And then we want to load in the room position. And then now we have the this here. So we say load in the room position. Actually, kind of curious, we don't probably need to be loaded in twice, because we're going to say set room occupied for room position. We're not changing it, so let's go ahead and remove that. And so we have our ASL. This is all the same stuff that we did before. And let's see. This all looks right. We set the room, the occupied. Well, let's see if this makes any difference. Okay, well, first off, we now have our up tile. That's a good sign. Don't have a door. Okay. Okay, let's take a look at what happened with that. Play stores. I thought I looked at that. No, play stores. So for play stores, we're going to start at 0. Okay. And then we're also going to set up this pointer for place doors. So the difference here is before we were only worrying about one room. Now we need to worry about all the rooms in the dungeon. All the rooms in the map, I should say. So we're going to need to do this in a loop here. So we're going to be going through all 64. We're going to say LDY 0, and then let's see. So the code's very different than what we had last time. So I'm just going to go ahead and type that in. So LDA temp adder 1 Y EQ done. So we need to have, let's see, do we have it done? Yes, but we need to add more stuff to it. So we'll do that when we get there. So basically it's checking to see if it's 0. We're gonna store it into doors, load the room position, and then we're gonna say ASL. The positions are 2 bytes wide. That's why we need to multiply. Then we're gonna set up the X register. And go ahead and put some comments in here. Okay. And it's Y load in temp place door and then if it's 0 we're going to go to done. We're done. Basically, if it's 0, then there's no place doors there. We don't have to worry about it. Most of the time, unless you have a full map, it's going to be going to done every time. So we're going to store that, into doors variable, and then we're going to load the room position. Okay, and now we have the same function the same stuff that we've had in the past, where we're loading in the positions. This is kind of a case where we probably should put a macro, but for now I'll just put it in here. LDA room positions, comma X. I'm gonna copy and paste this because I already have some nice comments for that. Okay, load in X coordinate, load in Y coordinate, and saving in room X and room Y. We have those already, right? Yes, we have those already. Okay, and now we don't need this stuff anymore. Now we have our check north, check south, etc. So we can actually change this to be doors. We're using doors instead of temp now. So we stored it into doors, and now we can say load doors and it with door north, check south, etc. Place north door, place south door, etc. Now for done, what we need to do is we need to increment the address, increment the room position, LDA room position, compare it with 64, because that's all we have is 64 rooms. So we're basically just going to go through this 64 times, 0 to 63, to make sure, just check all the place doors, and if there are any, we need to actually add them. And then we'll just do a BCC loop. Okay, so as I said, most of the time it's going to be 0. Okay, because unless the map is fully populated, at the beginning it won't be. Only have like 4 rooms, like we talked about. Most of the time we're going to be going down to done. But when there are some doors that actually need to be placed, then it'll get the room positions and then actually place the doors. Okay, so I believe none of the code changed for the placing of the doors. So let's go ahead and try that out. See if that works. Okay, it didn't explode. It's a good sign. Ooh, we have a door now. Yay! Okay, so we can only go right, looks like. Okay, so now we've got, okay, so it picked right again. That's fine. Cool. Picked right again. Okay, 3 rights in a row. Okay. And we also have our down tile. That's cool. All right. So it actually looks like it worked correctly. So let's play around with adding more rooms, okay? Just real quick, we only have 4. Let's see if we add, say, 8, just to make it a little bit more interesting. Okay, so probably gonna have the first 3 be, you know, to the right. Okay, we'll keep going here. Okay, so we hit a wall, so it should go either up or down. So it went up, up, up. Okay, so it looks like, oh, and then went left. Okay, so it looks like we have a bug here. And it looks like where the door is being placed on the western side. That's interesting. Okay. Let's go ahead and take a look. So placing, my guess is just an off by 1 error. We have our place room. Let's go with place doors and then place west door. Let's see. Place west door. Yes, it looks slightly different here. So I put in here the EW map pointer. So that's subtracted by 1. So again, it was an off by 1 error. Okay. And it looks like everything else is okay. So let's take a look now. Okay, we gotta go. It definitely makes it a little bit more longer to traverse when you have this many rooms. It'll be interesting to see what the balance will be on like the first levels, how many rooms it should have, etc. 8 seems like a bit much, especially for the first level. There we go. Cool. And we have our down. So there we have it. Okay, so that's all we have for today. A lot of code, a lot of stuff that I kind of glossed over a little bit. Let me know in the comments if you need me to go into more detail. As always, the code is up on GitHub. There'll be a link in the description. So there we go.
Thanks for watching. If you enjoyed the video, be sure to hit the like button. If you'd like to see more of this kind of content, be sure to hit the subscribe button and ring the bell. I post new videos all the time and I wouldn't want you to miss any. If you'd like to see more of this series, be sure to click up here. And if you'd like to see something else, be sure to click up here.